Hi, everybody. We are here with Brandon. Brandon is from the United States, from San Francisco. He loves to work with the communities, obviously. Thank you so much for joining us. Brandon is going to be here talking about UI on C#. So I don't know, what else can you tell us, Fede, about our next speaker?
Well, Brandon is a famous community attached guy. It works in a lot of applications. It makes developers to make apps look like 5-star apps. He develops a lot of libraries that make our life beautiful and easier and compact, and everything is faster when all the things that Brandon helped us to do. He has also be broadcasted on the Xamarin Show along with James Montemagno, and he's in every event that Xamarin is held on the world. So let the guy begin the talk, and he's going to talk about the UIs on C#. So let's bring it. Brandon, it's all yours.
Thanks so much, Michaela and Federico. It's so great to see all my favorite people here at Xamarin Assemble. Thanks so much for having me. We were just chatting a minute ago about how, as Xamarin developers, we don't get our own conference too often. And so I always love when we have 2, 3, 5 days devoted to nothing but Xamarin content, and I get to catch up with a lot of old friends. So thanks so much for everybody for coming out. And let's go ahead and make these slides full screen, and we'll jump right into it. So this session is all about creating Xamarin.Forms UIs in C#. And this is a topic that's near and dear to my heart because, like Federico mentioned, I have a lot of projects, both open source on GitHub. I think I've created and contributed to over 100 Xamarin.Forms repos on GitHub, and every Xamarin.Forms app I've built, I always use C#. I've rarely used XAML. I can only probably think of one library where I've created the XAML, unless somebody else has created it ahead of time and I'm helping to maintain or opening a pull request. But I've never really used XAML. And what I've found is while XAML has become the most popular language for creating Xamarin.Forms UIs, it's almost gotten to the point where there's folks that don't even know you can use C#. So I wanted to share with you a lot of cool things we can do in C# with Xamarin.Forms nowadays, and get into why I love it, and hopefully you'll love it too. So at the bottom of the links today, you'll see, or bottom of the slides, you'll see 2 links. On the bottom left, that is my Twitter handle. So if you have any questions afterwards, feel free to reach out to me on Twitter. My direct messages are always open if you want to chat anything about Xamarin. And on the bottom right, this is a webpage that I put together just for this session today, where you can find all of the resources we're going to talk about. So don't worry about memorizing anything, because that webpage has the slides. I'll post a link to the recording once it's available. There are links to learn more. The open source samples we're looking at today are linked there. So that's where you can find everything. And if you have any friends and family that couldn't attend today, you can also just send that their way to catch them up on the amazing world of creating Xamarin.Forms UIs in C#. So let's first just talk about the different UI options, because you might be surprised to know that there's more than just XAML. And starting with XAML, yes, this is the most popular. It's about 70% of Xamarin.Forms apps use XAML to create their UI. I have a hunch, however, that this is more of a self-fulfilling prophecy, because most tutorials I've seen, most workshops I've attended teach XAML. It's definitely the way to go if you were a WinForms developer or a WPF developer, using a language or using a platform that used XAML before. XAML is familiar to it. You can read it. It's very Yeah, probably familiar is the best word. But that being said, you don't have to use it. There's other options like CSS. And while CSS won't create your entire UI, you can use it for styling. And what's cool about this is if you are a web developer and you have experience with CSS, this is a great option. Or maybe on your team, you have a designer that doesn't know how to code. They don't know how to do XAML. They don't know how to do C#. That's okay too, because if they know CSS, then they can also jump in and help out with some of the code. There's Blazor mobile bindings. This one's kind of cool. This is basically using the technology behind Blazor to build native iOS and Android apps. So it leverages the XAML syntax. You can see the stack layout here on the slide, mixed with the Blazor syntax where we see the @code, open curly bracket. And this is still considered experimental. Now, what does experimental mean at Microsoft? If you see anything labeled experimental, it means that it is almost pre-alpha. This is something where we thought it'd be a cool tool that developers might love. And so we created it, made it open source on GitHub, and you can try it out today. But the way it'll become a real tool, the way to get something at Microsoft to leave experimental and become, I guess you would call it a real product, is just to start using it, talking about it, get the community excited about it. To be honest with you, that's actually how Blazor came about back in the day. Blazor was just a kind of a cool project made by Steve Sanderson, and he presented it at a conference at NDC Oslo and said, "Hey, I kind of put this thing together, thought it was cool, thought you might like it." And the community loved it. People couldn't stop talking about it. And more people presented it at meetups and conferences like this. And it took off and became, or left experimental and became a fully supported Microsoft product. So if you are familiar with Blazor and you want to try out Blazor mobile bindings, go for it. And if you are excited about it, talk about it, spread the word, do blog posts, get the community excited about it, because that's how we can get it to move out of experimental. And then, of course, lastly, but not least, is C#. This is my favorite way of creating UIs in Xamarin.Forms. And we recently had an update in Xamarin.Forms 4.6 that made it even more awesome, called C# markup extensions. Now, this isn't a presentation telling you should only be using C#. This isn't a presentation saying that you're wrong for using XAML. If you are using XAML today, great. Continue using it. It's an excellent choice. But when I started with Xamarin, actually, I joined Xamarin back in 2015. So about 5 years ago, I moved out to San Francisco to join Xamarin HQ. And that was, Xamarin.Forms had just become a thing. So Xamarin was the platform to create native iOS and Android apps in C#. So when I started learning Xamarin, everything was done in C#. And when I joined the company and learned about Xamarin.Forms and it started becoming a thing, I said, okay, I should probably learn Xamarin.Forms too. And I kept continuing in C#. And mainly that's because I had never used XAML before. I never really did web development. I did a couple websites when I was first learning to program, but that's it. And I never did WinForms or WPF. So I had no XAML experience before, and made a lot of sense to continue using the language I know and love in C#. So that's how I came to where I am today, and want to share with you kind of the pros and cons, because there's definitely trade-offs for both. I think one of the big things that XAML has that C# doesn't is hot reload yet. That's coming soon though in .NET MAUI and .NET 6. But let's take a look a little deeper and see what else is going on with C# versus XAML. So one of the considerations is performance. C# UIs will always load faster than a XAML UI. And this is just because of the way the languages work. C# is ahead of time compiled. XAML is interpreted at runtime. And because the bits are compiled ahead of time for C#, the runtime knows exactly what to do, and it can load your page faster than if that same page had been written in XAML, because the XAML will be interpreted when the user launches the app or when the user taps the button to navigate to a new page. And so, yes, C# will always load faster than XAML. Now, you might be thinking to yourself, but not for me, because I use the XAML compiler. I use XAML C. And yes and no. XAML C does help a lot. When it first came out, I guess this was maybe 4 years ago now, I remember playing around with XAML C, and I had a sample app that took about 300 milliseconds to load a page without XAML C, and then just flipping the bit, turning the XAML compiler on, brought the page load times down to about 150 milliseconds. So dramatic improvement. But XAML C only compiles some of the XAML, not all of it. And so there always will be some bits interpreted at runtime. Now, are we talking about drastic performance difference? No, with XAML C, it's pretty close. C# still a little bit faster, but if you don't have any performance problems with your XAML right now, that's okay. Like I said, keep using it. It's still a great option. Refactoring and maintenance, however, this one's a big deal for me. So things like binding refactoring. So Xamarin.Forms, we use MBVM. We have our views using bindings to communicate with our view models and back and forth. And one of the things I love about creating UI in C# is everything's done in C#. Everything is type safe. And when we come to refactoring, let's say I want to rename a property in my view model. So what do? Well, I would go to the view model. I would right click on that property and say rename, or we could use F2 in Visual Studio. And I enter in the new property name, hit enter. And with my C# UI code, the binding is automatically updated in my view. So then that change percolates both my view model and my views for every binding. With XAML, the binding is basically just a hard-coded string. And so what would happen if we were using XAML for our UI and we renamed a property in our view model? Well, now that binding still has the old name in XAML. And to be honest, we could run the app, it'll still build, but once we get to that page, we'll see those strange behaviors. So one of the tough things with refactoring and maintaining apps is the compiler won't even catch this because the binding is a string in XAML. Also in C#, if we want to find our binding references. So let's say you are new to a team that has an existing Xamarin.Forms app and you're trying to get up to speed. Or maybe you are fixing a bug that's in a different view model than the one you created, and one of your team members needs some help. So you jump in and say, okay, well, we have all these properties in our view model. Which ones are bound to which view? Well, with C#, again, because everything's typed out, it's all type safe, I can just right click and say find all references. So I can right click on the property in the view model that I want to find the references for, and I can just say F12, and it'll show me every view that's bound to that view model property. If my UI is in XAML, nothing shows up. And I've chatted with some fellow Xamarin.Forms developers, because this is a big deal for me, especially when I'm maintaining refactoring apps. So I asked them, I'm like, how do you find the binding references? And the best answer, or I guess the best solution I've heard so far, is just to use the search. So like find all and see where the names match up. And hopefully you haven't duplicated the name like is busy, because the search will show you where that binding is being used in every single file. Whereas what's nice with a C# based UI, find all references will just show you the bindings for that specific property. Statics and constants. This one's weird. This syntax has never really made sense to me in XAML. So if we first look at the C# UI here, we can see that I'm using a string constant for my automation ID. Well, because it's in C#, I can just type in the class name dot, type in, that's a constant field. Yeah, because properties can't be constant. So that's a class name dot field. And it just makes sense because that's how we're used to doing it in C#. In XAML, check out this syntax. We have to say automation ID equals double quote, open curly bracket, X colon, static with a capital S. Then I have to also add the namespace. This file lives in a different namespace. So I have to define this MBVM sample shared namespace above colon, and then I can reference the class name and the field name. And I don't know if it's just because I don't use XAML day to day, but I never remember this syntax. This is a syntax I always have to look up real quick because X colon static namespace colon class name dot field, that is not super intuitive for me, but in C#, it's exactly how we would expect to use it. Converters. This one is awesome in C#. So if you've ever had to convert a property in your view model to a different type in your view, so a popular one is, this one is an int to bool converter. So taking a integer value and turning that into a Boolean depending on some sort of conditional. Well, in XAML, we have to go create another file. We have to create another class that inherits from iValue converter. In this converter, nothing's type safe. We're working with objects, so object value, object parameter. And then we have to cast everything, hope we got the castings right, hope we do the convert back right. It's always tough for me to remember which way is which. And then once we have all that done, in our XAML, we can say converter equals static resource into bool. Great. Well, in C#, with the recent addition in Xamarin.Forms 4.6 for C# markup, if we want to do a converter, we can just say inline for our binding. So we say dot bind. I say I'm binding to the isEnabled property, to the text length, and then just say length doesn't equal 0. And what's cool about this is it's all type safe too. So I literally tell the binding, I'm binding to a button. I'm going to be passing in an int, returning a bool. And I have a nice type safe converter that's all in line. Didn't have to create a new class that inherits from iValue converter or anything crazy like that. And lastly, this is kind of my biggest point with C# versus XAML is I don't recommend that new Xamarin.Forms developers learn XAML straight away because it's another layer adding on to this existing very steep learning curve. Learning Xamarin.Forms is hard. To be a Xamarin.Forms developer, look at this. We have to know C#. There's over 100,000 iOS APIs we have to be aware of, 100,000 Android APIs we have to be aware of. We have to learn Xamarin.Forms. We have to know MBVM. We have to know how to use inversion of control so that we can do things like use a service locator or dependency injection to access the platform-specific code. We have to know asynchronous programming. And this list keeps going on and on. I'm still trying to become a good Xamarin.Forms developer, and I've been doing it for 5 years. And what I found is with new developers who don't already know XAML, adding in XAML, another language, another syntax that they're not familiar with, steepens the learning curve. So for new developers, this is why the workshops I lead in my intro to Xamarin talks that I give always show everything in C#, because that's the value proposition of Xamarin. It's all about creating native apps in C#. And yes, we can use XAML if we're already familiar with it. Okay, so enough talking about it. Let's check out some actual code. And I want to show you an app that I have that has a C# UI in it. So let's do my entire screen. Beautiful. All right. Here we go. And like I said, don't worry about memorizing anything. This app's open source. It's all on GitHub. And the links are all available on that landing page. And I'll make sure to give you another chance to grab the link if you haven't already. But here's an app that I called Xam Converter. It just converts units. So I love traveling, and I still haven't memorized how to convert between Fahrenheit and Celsius. So, today in San Francisco, it's about 65 degrees Fahrenheit. And for all my friends elsewhere, that's 18.3 degrees Celsius. Don't ask me why the US still uses Fahrenheit. I don't understand it either. But let's look at the code here, because what we have is a one-page app, and the layout is using a grid. So this is the same Xamarin.Forms grid that we know and love. And what I love with the C# markup extensions that came in Xamarin.Forms 4.6 is this new way of defining our rows and columns. So what I did ahead of time, I'm going to scroll down here, I created these enums, so enum row, enum column. And what I'm doing back in my grid is for each row, I'm giving a name for the row. And what I love about this is, I don't know about you, but I've messed up row numbers and column numbers so many times in my Xamarin.Forms apps, because, let's see, okay, is this row number 5, column 2, or wait, technically it's row 5, but the row numbers start at 0. So the row number is 4 for row 5. And I can never keep those straight in my head. And so with this, I can actually give an enum name to the row. And then I, again, just define this is the row height. So star, meaning that each of these rows are proportional to each other, except for the last one, which is twice as big. And likewise, for the columns, I have column label, column input that are both proportional. So this is my label column on the left. This is my input column on the right. And what makes this really cool is when I go to add my children to the grid, I can add the children in any order I want. And all I have to do is specify its row name. So this first one, dark purple label called, and then text is unit type. So this is this label right here. I just said this is in row unit type, and it's in column label. And I can see this, and it makes it so much easier to read, so much easier to maintain than just having to try and remember which control went in which row. And again, don't forget that they start at 0. So row 5 is actually row number 4, or I guess row 4 is actually row 5. See, I already messed it up. But with C#, we can identify each row and each column very easily. And we can also do our bindings in line here. So I can just say .bind, and then I can bind this picker's item source property to this property in my view model. And again, we're using C#, so I can take advantage of name of and avoid passing in a hard-coded string for my binding path. And like we mentioned earlier, I can right-click on this, say go to declaration. It takes me exactly to that property in my view model. If I wanted to rename this, let's say, don't do this in XAML. I jump back to my view. Well, look at that. The property name has already been updated. And likewise, we talked about doing a find all to see what is actually bound to this property from my view model. I can right click and I can say find references, and whoop, there we go. So on my conversion page, here's exactly where that binding's happening. Maybe I have a property called isBusy that's going to be bound to a bunch of different properties, and it makes all of this so much easier to read, maintain. But again, if you already know and use and love XAML, that's great. You don't have to use C#, but this is why I love it. And what's also really cool, also new in our Xamarin.Forms 4.6 C# markup extensions, is we can do things now like, check this out. So column span, if we look at, there we go. So this label at the end, it spans across 2 columns. So I can just say .column span, and I could have said 2. But what's also cool is I can say all and tell it to span across all the columns. And then I want the text here to be centered horizontally. .text center horizontal, boom, done. And same thing with that button at the bottom. I want that to fill and expand horizontal, done. So with C#, we get this nice type safe way of creating our UIs, easier to refactor, easier to maintain. And with all these cool extension methods like text center horizontal, fill expand, .row, .bind, we have this really cool syntax for creating our UIs now. Well, I guess since XamarinForms 4.6. Whoops, didn't mean to go back to the start. There we go. So that's great. But Maddie talked about MAUI, and I'm so glad she did because I only get 40 minutes with you all today. And so I actually was chatting with Maddie before. I was like, hey, you're talking about MAUI, right? And she's like, yes. And it's like, great, because I can show this, but I only need to talk and focus on this. So with .NET MAUI, we're getting some cool new tools for our fellow C# UI developers, one of them being hot reload. I can't wait for this. I mean, I've been creating my UIs for XamarinForms and C# for 5 years now, so I haven't lost anything, but I am pretty jealous of XAML hot reload. So I'm excited to get it with .NET MAUI. Support for VS Code will be really cool. But what I want to show off next is that model view update architecture. So model view update, MBVU, is essentially the next best paradigm. So right now, .NET developers, everything's done in MBVM. But if we zoom out of the .NET community, every other developer has moved on to MVU. So I love seeing that .NET MAUI is introducing MVU as a first-class citizen. But to be honest with you all, we're a couple years behind the rest of the developer community. But I'm excited to be catching up. And what I want to show you is how we can start preparing for C# and MVU today. Because like Maddie mentioned in the keynote, .NET MAUI won't be available till later this year. And even then, it'll only be released in preview. So we've got about, that's about half a year till preview comes out, and then about another year till it hits stable. So we've got about a year and a half to start preparing and start learning MVU and C#. And what I want to introduce you to is this framework made by James Clancy. Let's go ahead and bump up the quality. This is a framework called Comet. James Clancy, if you haven't heard of him or met him before, he's one of the smartest engineers I know. He and I worked together at Xamarin and still work together at Microsoft. And he saw Apple announce SwiftUI last year at WWDC and said, hey, that's pretty cool. I wonder if I could do that in C#. And he did. He spent a week, like I said, only a week. This guy's a genius. Spent a week, started playing around with this, and cranked out this framework library called Comet. And you can see he's doing everything in C# and similar syntax to what we saw with our C# UI in XamarinForms and that sample app in XamConverter, where we're newing up things, extension methods that allow for this fluent syntax. But Comet, you'll notice, has C# hot reload baked into it. So that iOS simulator on the right, that's updating in real time as he's typing the code. And he chose to make MVU the default framework or recommended framework for Comet apps as well. And this debuted around this time last year and has since become the inspiration for MAUI. So a lot of things that we learned from Clancy's Comet project will be bringing into MAUI. Now, I can't guarantee it'll be I can't guarantee that MAUI's implementation will be exactly the same as Comet's implementation, because like Maddie mentioned, we're having these awesome discussions with you all on the MAUI GitHub repo. So we're open to pretty much changing anything. But what we can do now is play around with Comet to start to get a feel for C# and MVU. And let's do that now. I have another sample app. Don't save. And while that's loading, I'll show you what this app looks like in the simulator. This is another one pager. And because I'm using the simulator and because this app requires my geolocation and the simulator doesn't have GPS, we just see a bunch of unknown values for latitude and longitude. Let's make this bigger. There we go. So if I was running this on my device, it would show my geolocation here. But what we want to focus on is the code. How did I write the code for this app using MVU. So yes, it's all in C#. That one's pretty obvious. And I do want to point out, this is using the Clancy.Comet NuGet package. So it's just a NuGet package for Comet. We can add it into our apps and start using it today. But what's going on here? So we have this method called generateBody, and this is where we are creating our view. So our view is just a couple labels, some text on the screen, right? And the first thing you'll notice with generateBody, this is a method. This is a function. And what this function does, it first creates a new VStack, so a vertical stack. And in that stack, we've included a title text, a label text, and just to show you, these are just some classes I made down here. So title text, instead of rewriting this code 3 times for the same, or for the 3 titles, just figured why not create a little class down here and I'll reuse the code. I totally could have done the same thing up here and just said fill horizontal, but in the spirit of sharing code, like we love doing as Xamarin developers, thought I'd put them into a class. But what you'll notice is some of these take in a string and some of these take in a function. And so the ones that take in a function here are pulling a value from this variable called location state. So location state is up here. It's a read-only state object of type location. Location, this is just from the Xamarin Essentials NuGet package. So location just contains, let's see, will IntelliSense show it to me? That's okay. So location will show us our latitude, our longitude, our heading, our accuracy, all that fun stuff. So I've decided to use that as my model. And what happens is when this app first runs, it calls generateBody to draw the view. And then what my app is doing, I have this infinite loop going where every second, so once a second, I check the geolocation to see if it's updated. And if it has updated, I set that value to location state.value. Now, this is where model view update comes in. So our view is right here. Our model is here. And the update happens when location state.value changes. So when location state.value changes, we call generateBody again, and we update the UI. So that's why generateBody is a function, because we're going to be just calling that function every time. Now, you might be thinking to yourself, hang on, that has got to be the most inefficient way to do this. And that was my first thought too. It's like, there's no way that my app is going to work without flickering. If it's constantly refreshing the screen, that can't be good. Well, it turns out, again, we're a couple years behind. This is already how React developers, how Flutter developers are creating their apps. Turns out it is totally performant. And yes, we're still working on MAUI, but chatting with James Clancy, he's said that .NET MAUI is also going to have some logic in it to be able to basically determine the diff. So if nothing changed, like this title will always stay the same. It's hard-coded to lat long. We don't need to update that. If the latitude didn't change, but the altitude did, let's only update the altitude. So there will be some performance capabilities in .NET MAUI to help improve this even more. But this is essentially model view update in a nutshell. So our view is generated inside of a function. We have a model, which is our state. And anytime that state changes, we run we run that function to update our view. And I will say one of the things I really love about MVU. Now let's do 2 things. The first thing I love about MVU is we don't have to have all this overhead of a view model. And what I mean by that is you may not notice it because if you're like me, you've been doing MVVM for years now, but the view model essentially duplicates the model. So a C# model, your POCO, that contains properties in it. But to bind those properties to the view, in our view model, we actually break that out into individual properties on which we can call onPropertyChanged. Well, with MVU, we don't need to do any of that. That's all just overhead for MVVM to work with bindings because MVU has everything here in one location. So with MVU, the first thing I love is we don't have to write as much code. And then the second thing I love, or the second thing I'm really excited about, is I love GraphQL. GraphQL, I mean, this is Brandon talking, but Brandon says that GraphQL is the future. And I truly believe in 10 years, GraphQL will be the default framework for creating your backends. I think I see a world where the same way we look at REST versus SOAP today, like if somebody says, hey, Brandon, can you help me debug my SOAP API? The first thing I'm going to say is, why are you still using SOAP? And hopefully they have a good reason. But 10 years from now, I see that same conversation happening with GraphQL and REST. But this isn't a talk on GraphQL, it's a talk on MVU. And the cool thing with MVU is your logic can actually live in your GraphQL backend. So we can actually have that update come from our backend API. And so we could create our apps without having to write any logic. They're just essentially dumb views that update anytime our pub sub subscription to our GraphQL endpoint tells us that something's changed. So lots of exciting things coming in the future. Let's see. We have about 3 minutes left, but that is how we can get started on C# and MVU today. We can try out Comet. If you haven't had a chance yet, now's the time. Grab a screenshot of this slide or bookmark this link, share it with your friends and family that couldn't make it today, because this is where I've put everything from the slides to those open source samples. If you want to see a real world app, I've recently launched a new app to the App Store called Git Trends. It's used to help monitor the views and clones of all of your GitHub repos. Shout out to Luis, who made a beautiful UI for it. And there's actually a couple more folks in the conference today that have also contributed to Git Trends. So thank you. But Git Trends is totally done in C#. There's no XAML in there. So if you want to check out how a real world App Store app is using C#, I've also made sure to link to Git Trends from this landing page as well. Thank you.
So thank you very much, Brandon. That was a great talk. I can't believe what I'm seeing. It's all over the place, the MVU pattern, we can still write code in MBVM. And we have a couple of questions here. How about unit testing MVU? What do you think about that?
Let me stop sharing. Let's come back. Hi. Let's see. Can you repeat the question again?
Yes. One of the people here asked, how about unit testing with MVU? What can you tell them?
Oh, unit testing.
Yeah.
That's a good question. I personally haven't tried it. I assume it's got to be possible. I'd be shocked if it wasn't. But I tell you what, I'm going to take that on. I'm going to take the app that we were just checking out and see about if I can add a unit test project, because that sounds like a fun challenge. And yeah, we should be unit testing our apps, right? Yeah. We all write tests, right? So yeah, I'm sure it's doable, but have I done it yet? No.
Okay, yeah, right. Let's see it. So before we move on another question, how did you feel about moving from an MBVM approach to MVU? Was it fun? Was it fast? Was it hard? Is it simpler than it is?
So, I mean, it's weird at first, just like any new technology, new framework. It's going to feel a little weird because you've never done it before, or I had never done it before. But once I started playing around with it, I loved how quickly we were able to create apps. So without the overhead of having a view model, that when you compare the two, the view model really just duplicates everything in the model and then adds the context or adds the logic around it. And then we don't have to write that code anymore for MVU. And one of the biggest problems and where bugs come about for MBVM apps is because of the state. You might have a view model that has 20 properties in it that all can be set to any value. So if it's a string, there's infinite possibilities. If there's a Boolean, then true, false. So each of these properties can have a different value. And when you start adding and multiplying together to figure out how many different states could my app be in at a given moment, it becomes insanely complex, like hundreds, thousands, if not infinite states that this app could be in. And we have to make sure we account for all of that. And when we don't, that's how bugs happen. So the nice thing about having this one state object is we can actually look for things when the state changes. So if the state changes, but let's see, I'm trying to think of an example with this geolocation app, but let's say that converter app. So the state changed because we want to measure or convert Fahrenheit to Celsius. Well, we can have some logic in our update flow that kind of acts like a gate to say, well, if we're doing Fahrenheit and Celsius, the app should always have these values. And we can make sure that we don't have these weird edge cases that sneak into our app, because we can kind of do that gatekeeping in that update loop. And so having one variable to manage state we'll say should, because we still have to write good code, right?
Yeah.
But should help us avoid a lot of these state problems that pop up in MBVM.
Excellent, excellent. It's great to hear that. And I can't wait to move on and to try everything about MBVU and everything that is going on, and every library that is going to be built with this fantastic technology. I can't wait to see it. And can you tell me, what do you think about the future of MBVU? What is going to make, or what it's going to make our life easy? And I am really interested about GraphQL. So is GitTrends using GraphQL now?
It does. So the GitHub API, GitHub has, we'll say, it has 4 versions of its API. The newest one, V4, is all GraphQL. So GitTrends uses the GitHub API, uses the GraphQL API, but GitHub is still migrating everything from the REST API, so V3 API, into V4 GraphQL API. So there's a couple API calls I still have to make to the REST APIs. But yeah, that's a great point. If you want to check out how I did it with GitTrends, it's all open source. And like I said, it's a real world production app using GraphQL. And there's the reason I say GraphQL will be the de facto backend of the future is just the performance benefits that it grants us, especially as mobile developers.
Yeah,
we want to make calls to our API as little as possible, and because we don't have infinite power, we're running on a battery. We don't have infinite CPU cycles. We're running on, well, phones nowadays are getting more powerful, but there's still older Android devices that aren't as fast. And so we want to make as few API calls as possible. And the data that comes back from the API should be slimmed down as much as possible. And GraphQL helps us do that. So with the GitHub GraphQL API, for example, I can make one API request to the GraphQL endpoint and say, give me all of my repositories. And for each repository, give me the name of the repository, give me the description of the repository, how many stars it has, give me the owner, give me that owner's user profile, name, and image. And all of that is just one request. So with one round trip, I can get all the data I need for the app. Whereas with REST APIs, I would first have to say, I would make one request to say, give me the information about this user, and then it would send back the user ID. And then I could use that user ID to ask for the repositories. And repositories would come back. And I would say, okay, for each repository, now give me its stars and views and clones. And so with GraphQL, it just condenses everything into one API call. So it's really beautiful, and it allows us from the mobile side to write more efficient or do more efficient API queries, but also it gives us the power to request whatever we want. So if I want to change the shape of the response so that the data that comes back, if I want to also add in the date you created each repo, I'm not fetching that right now, but I could just add that into my original request. And now the response will include that. So it's, again, just one round trip, get all the data I need. And it's not more than I need. It's not multiple round trips. It's a really beautiful framework. And with MVU, React apps, Flutter apps are already leveraging the fact that GraphQL also has this capability for subscription. So basically like a pub sub kind of architecture. And so your GraphQL backend can just send you these updates. So every time something changes, kind of like we have in .NET with Signal R, that similar kind of real-time updates, we can just connect to our GraphQL backend. It gives us these real-time updates. And then all our app code has to do is draw the UI and handle that update loop. So it'll be this beautiful future I see in a couple of years. Yeah.
Yeah, it's become really minimal, and everything is going to be more powerful and more handled from the server code. And it made the app upgrades or change in a way that is really faster than we do today. So I think that's really, really cool, and I love that feature. And about building the XamarinForms UI with C#, I have one question. What's the coolest features you can think of right now that is done with C# and not with XAML that you prefer the most?
I mean, I touched on a couple of them in the talk, but I think my favorite is those converters. So now I can have type-safe converters inline. I don't have to create another class. I don't have to inherit from iValue converter. It's just there. And so just that simple overhead, and then coupled with the fluent syntax, and it's just become a really great way to write our UI code.
Yeah, and you spare some files too.
What's that?
And you don't have to have multiple files as well, because with XAML you have to have one or two files also.
Yeah. That's what's always funny when I tell people that I do all my UIs in C#. They're like, you do your UIs in the code behind? I'm like, no. There's no XAML. There is no such thing as code behind. This is just C#. We're still doing, and because then the next question is like, yeah, but you have to use XAML for MBVM. I'm like, nope, we're still using bindings. It's still the view. We still have a view model. Nothing's different. It's just the language.
Yeah. And last question. How do you feel about partial classes for great or big UIs, or very complicated or advanced UIs? Or what are your feelings, your advantage, or what's the advantage of doing that on C#?
Yeah, so that will become the norm with .NET MAUI. I wish we had more time because I had a kind of a deep dive into .NET MAUI queued up. But basically, with a single, with a multi-targeted single project, you have access to the iOS APIs, the Android APIs, .NET Standard APIs, all from the same C# project. So all from the same, the same CS proj file. And what's cool there is you can start to use partial classes instead of having to use a service locator or a version of control. We can just use a partial class to access those platform-specific APIs. So when .NET MAUI comes about, you're going to see an explosion of partial classes. Now, today, I'm not against it. I've started doing it in some places where, maybe I have some extension methods that don't need to be in the original class. But what I've seen, Vincent Huggendorn, he's the guy that actually created these C# for markup extensions. Did an awesome job. Love you, Vincent, if you're out there. He breaks up his C# classes into partial classes and does a UI class and does a logic class. Mm-hmm. And I do like that because you can have your like your event handlers and all that stuff in one class. And well, it's a partial class, so technically it's the same class as the compiler, but different file. And then have your UI elements in a separate file. So I like the idea that there's a couple things that trip me up, like if I want to create a field in the constructor and mark it read only, well, now both partial classes can't have a constructor. Only one of them gets the constructor. And how do you choose? So I haven't leaned into it as far as Vincent has, but I definitely see the benefit, and it will become the norm once we start diving in the world of .NET MAUI. So why not start getting used to it today?
Yeah. Well, Brandon, I can't thank you enough for this great talk. but unfortunately, we have no more time. I hope you see you soon, and this was a great talk.
Thanks so much, Federico, and thanks everybody for joining me. Well, I'll see you in the next session.
See ya. Bye.